This is a video for the CAPS Dbe Nsc, November 22, paper 1. Starting with question 1.1.1, we have two brackets equal to 0. So if we start with our two brackets, we have 3x minus 6 and x plus 2 equal to 0. Either 3x minus 6 or x plus 2 must be 0 in order for this to be true. So we can say 3x minus 6 is equal to 0 or x plus 2 is equal to 0. We need to get x on its own, so we're taking 6 over the equal sign by adding 6 to each side. And we can divide by 3 on both sides, and 6 divided by 3 is 2. So x equals 2 on this side. On this side, we minus 2 from both sides, and we end up with x equal to minus 2. And that's 1.1.1. 1.1.2, 2x squared minus 6x plus 1 equal to 0. Corrected 2 decimal places. This is a hint to use the quadratic formula. So we know that x is going to be equal to minus b plus or minus the square root of b squared minus 4ac all over 2a, where a is our coefficient of the x squared term, b is our coefficient of the x term, and c is the constant term in standard form. So we just sub in our values, we end up with minus 6 plus or minus the square root of minus 6 squared minus 4, 2 times 1 all over 2. A value is times 2. If you put this into your calculator, putting it in separately, so you'll have minus 6. I prefer to keep it in this exact form. So it'll be minus 6 plus all of the above, or it'll be minus 6 minus all of the above. So if you put it in your calculator, you need to do two separate sums. Obviously, just keep the first one and change the plus to a minus in the second option. And from this, rounded to 2 decimal places, you should get that x is equal to 2.82 or 0.18. Those are your two options. Just a note on the Casio calculators, this one would have been 3 plus square root of 7 over 2. And then you just press the SD button, and this little S to the D button will give you your decimal form. And the same thing here, we'd end up with, I think it would probably be 3 minus square root 7 over 2. Let's quickly check on my calculator. I'm using a Casio FX82. Yes, so 3 minus root 7 over 2. The S to the D button will give you your final decimal answer. There are a couple of Casio calculators that are allowed. The FX, I think 911 or 991 is a bit better than this one, but both work. Number 1.1.3, we have quadratic inequality. So it's currently not in standard form. First thing, we bring the x over to the left-hand side by minusing x from both sides. And we end up with x squared minus x minus 90 equal to 0. I look at 90 and I see probably 90 has quite easy factors of 10 times 9. So I would immediately just open myself some brackets. We know that x times x makes x squared, and 90 using 10 and 9. The third term is negative, so the signs will be different, and the middle term is negative, so the bigger number takes the sign of the middle term. So it's minus 10 plus 9. It makes minus x. So, adding together to make the middle term, timesing together to make the third term. But we're not done, so we need our critical values, and this is where our brackets are equal to 0. And our critical values is x taking the 9 over the equal sign, so x plus 9 is equal to 0. X plus 9 is equal to 0. If you take the 9 over the equal sign, we minus 9 from both sides. X is equal to minus 9. Or x minus 10 is equal to 0, because one of these brackets must be 0 for this to be true. Plus 10 on both sides, and x is equal to 10. So these are our two critical values. Using our critical values, we can start doing our inequality. We know that it's either going to be a smiley face or a frowny face parabola. The way we find out what it is, we look at our original equation and we see our a value. Our a value was positive here, and because it's positive, it's a smiley face. So we know we have a smiley face as our inequality. We draw a line to represent where y equals 0. The question is asking, what are all the values of x that will give us the y's that we want? At the moment, all we have is the critical values, so we only have where the x's where y is 0, which is put the smaller one on the left, minus 9, and the bigger one on the right is 10. So far we have a positive quadratic inequality with our two critical values. We still need to know whether we're looking at the bottom or the top. And the way we find that is we look at this inequality sign. This is saying the function is larger than 0, so therefore we want where the function, so where f of x, our function, which is just the y's of f, where are the y's of f larger than 0? And of course that's up here. So the y's of f over there and over there are going to be larger than 0. So we can deduce that when x is less than our critical value minus 9, or when x is bigger than our critical value 10, we meet the requirements of the question. For 1.1.4, we have a third equation. X minus 7 square root x is equal to minus 12. Okay, so first thing I usually do in these is I take the third and I change it to exponent form, and that's because of the exponent rule. The nth root of a to the power of m is equal to a to the power of m over n. So using this rule, I immediately change it to x minus 7 x to the power half, and at the same time we can plus 12 on both sides to bring 12 to the left-hand side, and we've got it equal to 0. So now we have, in fact, a trinomial. The way to recognize this trinomial is that this x is actually to the power of 1, and the middle x is a half of its size. So a trinomial can be recognized that if there's 3 terms, the first x is double the middle one. So we can open up our brackets as normal for a trinomial. So x. Now, just to know that you have x to the power of half here, because the square root of x times the square root of x is equal to x. So we're using this rule. So obviously, if you look at this rule, that would also be that a half times a half. We could easily just say, well, this is a half plus this can simplify to x to the power of a half plus a half, which is x to the power of 1. Whichever way you look at it, this works. We've got 12. It's got to times together to make plus 12, and it's got to add together to make a 7. So 4 and 3. 4 times 3 makes 12. The third term is positive, so our two signs are the same, and they both take the sign of the middle term. One of these brackets must be negative, therefore we can say x to the power of a half minus 3 is equal to 0, or x to the power of a half minus 4 is equal to 0. Quickly taking the negative 3 by adding 3 on both sides. X to the power of a half is equal to 3. Do the same on this side. X to the power of a half is equal to 4. To get rid of this exponent, we can raise the power to 2 over 1. And of course, what we do on the left side, we have to do on the right side. This is using the rule of exponents. If a to the power of n, a bracket is raised to the power of n, then it's going to be, you times them together. So we times fractions top by top, bottom by bottom, so it'll be 2 over 2. So x to the power of 2 over 2 is just x to the power of 1, 3 to the power of 2, which is 9. And on this side, again, x to the power of 1, and we have 4 to the power of 2, which is 16. Number 1.2, solve for x and y. Simultaneously, we have 2x minus y equals to 2, and we have xy equals to 4. A couple of ways you can do these. One way is to get a y on its own on each side, and then y equals y, so the right-hand side will equal the right-hand side. So just to quickly take you through that, we'd end up minus 2x over here, so minus y, and you can divide by minus 1, so it'll be minus 2 plus 2x equals y, and this would be one equation. We could label that number 1. This side's much easier. We just have to divide through by x. Those cancel out. Y equals 4 over x. If you're using this method, we can label this equation number 2. If you're using this method, we can simply let our equation 1 equal our equation 2. So 2x minus 2 is equal to 4 over x. From here, we can quickly just rearrange to make x the subject to solve for x. First thing we need to do is make a lowest common denominator of x. So 2 times x over x is 2x squared over x, and minus 2 times x over x is 2x over x. And the 4 is already over x, so we're okay. Solve once you've got all of them into lowest common denominator, we can drop the x. We end up with 2x squared minus 2x, bring the 4 over, minus 4 equals to 0. Here I would just quickly take out a common factor of 2, x squared minus x minus 2 left over. If we divide through by 2, 0 divided by 2 is still 0, so we can just cross that out. X squared minus x minus 2 equals to 0. Opening up my brackets, 2 is a prime number, so it's just going to be 2 and 1, x and x. Once we've got, the third term is negative, so we know that 1 is negative and 1 is positive. The bigger number takes the sign of the middle term, so that one's going to be negative. One of these brackets must be equal to 0, so therefore either of them could be equal to 0. You can split them. So x is equal to minus 1 on both sides to get rid of that minus 1, or x minus 2 on both sides to x being equal to 2. Another way we could look at this question is just by substitution. So the substitution method in this case, we could leave this one exactly as it is and just call that number 1. And then on this side, it's very easy to rearrange as we saw before. The y is equal to 4 over x, and we can call this number 2. And instead of letting one equation equal the other, we can sub our second equation as it is into the first equation. So we're subbing number 2 into 1. So what that means is every time we see a y, instead we just switch it out for 4 over x. So 2x minus 4 over x is equal to 2. This method, excuse me, this method's often quite a lot quicker to do if you see it. And from here, it would be the same as before. We would have to solve for the x. You could just finish it up. So making an LCD for x over x, and it's 2x over x. Drop the LCD. Let's see if it works out. Something wrong here. Whoopsie daisies. The x was already there, so whoop. 2x squared minus 2x minus 4. And taking out 2 as a common factor. And yeah, we end up with the same thing. Whichever method you chose to use, the easiest version to get y would be to sub it back into this side. So just sub your x values. Wherever you see an x, you put your x values. So y is going to be 4 over minus 1, or y will be 4 over 2. This just simplifies to minus 4, and this one simplifies to 2. And that's the end of that question. Number 1.3, 2 to the power of 5n minus 5n plus 1 plus 5n plus 2. We were required to prove that it's even for all positive integer values of n. So n is a positive integer. This means that n will be a negative or positive number. So the way that I look at these sorts of questions is first rearrange it a bit and see what happens. So I see that 5 to the power of n can be a common factor here. If you take out 5 to the power of n as a common factor and you open your brackets, what's left over here in the first term is 2. So 2 times 5 to the power of n would equal that. The second term, we could use the rules of exponents to expand this to 5 to the power of n times 5 to the power of 1, because 5 to the power of n times 5 to the power of 1 is 5 to the power of n plus 1. So the second term, when we take out 5 to the power of n, we end up left over with a 5 to the power of 1. And then the third term, using the same thing, is 5 to the power of n times 5 to the power of 2, laws of exponents there. So we end up with plus 5 to the power of 2. So if we just simply add these up together, 5 to the power of 225 plus 5, minus 5 plus 2, we end up with 22. Now, it's saying that any number, so an integer minus 1, 1, minus 2, 2, etc., 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 can be, we're going to end up with an even number. The way I look at these sorts of questions is I let n equal -1 and I let n equal 1. And I see what happens. So if n equals -1, then let's see what happens to this. It'll be 5 to the power of -1 times by 22. This is actually just 1 over 5 times 22 using the laws of exponents, because 5 to the power of -1 is actually over 1, and the negative exponent on the top is a positive exponent in the denominator. So this is 1 over 5 to the power of 1. It's using those laws of exponents. Quickly putting this into my calculator. First of all, you get the answer of 22 over 5. press the S to D button, and you'll get 4.4, which is even. Then I try 1, let n equal 1. So now I'm taking care of another option. And this, obviously, you don't need so many. Minus 1 and 1 is enough. So I let n equal 1. It'll be 5 to the power of 1 times 22. So it's just 5 times 22, which is 110, which is also even. From this, I can deduce that if I multiply any integer, the answer will be even. And that's what that was required to prove for question 1.3. Question 1.4 of the 2022 November paper is not my favorite type of question. It asks you to determine the values of x and y, but it's only given you enough information, really speaking, to get sort of y in terms of x or x in terms of y. So, when I see something like this in an exam, I'm not happy. So I just follow the steps that we know. So the first step is to prime factorize, because we have an x and a y in the exponent. So anyway, if you have that, you should prime factorize. To prime factorize 32, then you just press 32 equals on your Casio calculator. Now that'll store the 32, and then shift, which is above the sort of blank blue button, and fact. Fact is above this thing that looks like this. And that'll give you your real prime factor of 32, if you don't know it out of your head. So it should be 2 to the power of 5. Yes, that's correct. Okay. 2 to the power of 5, 96, same method. Prime factorize 96, press 96 equals, shift fact. This will bring us, just keep it in a bracket. So remember that it's all to the power of x, and that square root is still there. 2 to the power of 5 times 3. So we've prime factorized everything. So now I already see, okay, we have a common base of probably of 2 and 3. So I already see, okay, maybe we can do something with that, but I want to get rid of that surd. So I change the surd to this 8 power of x. This is basically just this. So the surd is just a square root. We'll end up with x over 2 as our fraction form. So bringing this down, let's take this slowly. So this is still there, but now this is all raised to the power of a half. I just took it one step at a time, and of course, using this rule on the right, you could have done it all in one step. So it would have been just simply x over 2. But if you see here, x times 1 and 1 times 2, whichever way you did it, would have still worked out. Top times top, bottom times bottom. Here we have, just to get rid of this, we times it into both. So 5 to the power of 5x over 2, and times by 3 to the power of x over 2. We'll bring down our left-hand side. It's looking good, but I don't see any, usually you'd have just a 3 or a 2 to work with. So let's bring this 2 to the power of 5 to the top. The exponent at the bottom is negative at the top because it's positive at the bottom. So 3 to the power of y plus 1, 2 to the power of minus 5. And I'm looking at this and I'm thinking, okay, so nothing I do here is going to easily get x or y on its own, which is the goal. So we have to use a little bit of logic. So I said these are my least favorite types of questions because of the need to sort of use logic instead of actually solving the problem. So from here, if I look at these bases, if we take the base 2, since it's the only 2 on the left-hand side and it's the only 2, oh, this is a 2. Yeah. Oopsie daisies. Because this is the only 2, oh, let's just check that that worked out. Where did that start? Hmm. Because this is the only 2 on the left-hand side and this is the only 2 on the right-hand side, we can deduce that 2 to the power minus 5 by logic must be equal to 2 to the power of 5x over 2. So we've sort of split this up. As I said, these are not my favorite types of questions. We can deduce this. So using this information, if we take this on its own, you can drop the 2's, drop their bases. So you have minus 5 equals to 5x over 2. Minus 5 times 2, so get rid of that 2, times 2 on both sides is minus 10 equals to 5x. And the last step, divide both sides by 5. And we have x equals to 10 divided by 5 minus 10 divided by 5 is minus 2. So it's a bit of a fuzzy logic, not my favorite type of question. Then on the other side, we can say, well, this is a base 3. 3 to the power of y plus 1, because there's only 1, 3 on the left-hand side and 1, 3 base on the right-hand side. It must be equal to 3 to the power of x over 2. We sub in our x value that we got from doing the 2 base, and our x value was minus 2. 3 to the power of y plus 1 is equal to 3 to the power of minus 2 over 2, which is just minus 1. Drop the bases, y plus 1 is equal to minus 1, and taking the plus 1 over to the other side, y is equal to minus 2. And that concludes question 1. Please like if you like my videos and subscribe.